Here. And my name is Damian. I'm co-founder of Composable Security. We provide security services to various Web3 projects. You may know us from SCSVS, which is the first security checklist that we have created back in 2018, 2019. And of course, we do audits, so I'm a security researcher. And today I'd like to show you some security insights on Uniswap v4, which is going to be released next month. So they're at this end step of their security journey now, so just before the release. And I'll focus on the architecture, so the differences between v4 and v3, and also show you some examples of the security threats and how to be secure, simply. So let's start with a simple question. Who knows this equation? Raise your hand. All right, so this is, of course, Uniswap v2, the most common, I would say, version, the big success. Why? Because it was very simple. That equation was like the core of their project, right? That was the core of v2. But it had the downside, the inefficient liquidity. So whenever you put any liquidity in Uniswap v2, you put it on the whole range. So most of the liquidity is almost never used, right? So that's how the v3 has risen, right? The main thing about v3 was this concentrated liquidity. So you put the liquidity in a specific price range. It made your liquidity could be very easily fully used, right? And you earn more fees. So that was the upside. The downside was that now you cannot use ERC20 to represent the liquidity, so they had to use NFTs to represent the positions whenever you add liquidity. So the architecture of v3 was that you had this Uniswap v3 factory, and whenever you wanted to create a new pool, you had to call it, and it created it deployed a new pool. So each pool was a separate contract in v3. Then when you are a liquidity provider, you have to use this helper contract, which is called non-fungible position manager. That was an official contract by Uniswap Labs, and it calls the Uniswap pool on your behalf. The Uniswap pool does the callback, and the callback is handled in this non-fungible position manager. So you actually, it's transparent for you as the user, right? Even though there are those callbacks there. And then when you do swap, it's very similar. You also have to use this helper contract called swap router. And there is also this callback mechanism. Oh, you cannot see that much, but basically you call the swap function and it calls back your swap router, and the swap router accounts your balances, right? And now, over 3 years after v3 has been deployed, there is 90% of the new pools that are created are still v2, right? And also there is still over $1.5 billion of liquidity in v2. So that's the idea behind v4, one of the ideas, because the goal here is to make it even more gas optimized than v3, to make it customizable, and also attract LPs, possibly, to move from v2 and v3 to v4. Because now v4 can also be a v2. And I'll show you an example in a sec. And there are some changes. I'm going to cover them on future slides, but one of them is the big one, right? The transient storage, which came with Denkun, that allows you to really decrease the gas cost of some operations, like semi-storage operations, let's say. So what's the first difference? The first difference is the pattern used in v4. So there are no more multiple pools, multiple contracts for pools. There is one contract that manages all pools. It's called Pool Manager. So it stores in its storage mappings information about all the pools. It has all the tokens on it, all the liquidity is in one contract. Then you have this contract, this helper contract called pool operator, which has this lock mechanism. So it's not like you make a call to add liquidity and then get callback from the pool, but now you make a call to unlock function. The pool calls you back with unlock callback function, and from this point you can make a lot of different operations like minting liquidity, removing liquidity, swapping, doing whatever without more callbacks. You do it directly on the pool manager, and in the end the pool manager checks whether your accounts are settled. So you cannot owe any money to the pool manager, and pool manager cannot owe you any money. It has to be cleared, and then it's successful, right? So it's not reverted. So this is this locking mechanism, and also flash accounting, because you can make those operations on multiple pools. You call the same contract multiple times, but do the operations on multiple pools, multiple assets, multiple fees, whatever you want. And then the biggest change, the hooks. So whenever you make an operation on a pool, the pool can have a hooks contract associated. So, and then if there is a hooks contract next to the pool, it gets called on multiple operations, before and after swapping, before and after adding liquidity, before and after removing liquidity. So it's not like it's always called, but it can be called. The hook contract tells the pool manager when to call it with these flags. So if the hook has set flag, for example, before swap, flag set, then the pool manager will call this before swap function or before initialize function, just before the pool is being initialized. And this also gives you some additional power as the hook contract, because you can manage the fees now. So you can even change the amounts being swapped and returned to the user. And if you set the amount to be swapped to 0, you can actually do any other curve. So you can cover any other curve in the hook. And just simply saying that we will not swap any tokens on the Uniswap v3 pool. So you can have a pool which is functioning pool without any liquidity on it, because the liquidity stays on the side and is used whenever you need it. Just as an example. So now let's move to the meat, the security of v4. We have done a threat modeling session for v4, and here is an example of some threats. All those clouds are the threats, and today I'm going to focus on a few of them, specifically on 6 of them, and I'll just move forward because you cannot read it now. So the first one is an authorized direct call to hook contract. And here is an example of a hook. This is a full range hook that you can treat as Uniswap v2 on Uniswap v4. Because whenever you add liquidity to a pool that has this hook, it puts the liquidity on the whole curve, on the whole range. So like Uniswap v2, right? And also it creates, just before you initialize a pool, it creates ERC20 token that represents the liquidity on this curve. So you can think of it like Uniswap v2 on Uniswap v4. But the problem here is that the before initialize function, so one of the hook functions, it is external because it's called externally by the pool manager, right? So it has to be protected somehow. In this example, it isn't. So anyone can call this before initialize function. It should be called only by the pool manager when you initialize the pool. So when you call the initialize function on the pool manager, but now anyone can call it, and simply what happens if you call it again directly? It creates another ERC20 and overrides the previous one. So if somebody added any liquidity, they got the previous ERC20. Now when they want to remove their liquidity, the contract will try to burn ERC20. But as we called this before initialize directly, it's not this ERC20 anymore. It's a new one without any balances. So this burn will revert, and you will not be able to withdraw your liquidity. So your tokens are locked. How to protect from that? Simply add a modifier which checks whether the call comes from the pool manager. So only the pool manager can call your hook contract. And actually, that's it for this thread. Another example is on the other side. So it's also an unauthorized call, but to the unlock callback. So the call flows looks like this. There is a user. He calls some function on the pool operator, which is this helper contract used to operate on pool manager. And the pool operator calls the unlock function and passes some operation, some data. This data is returned in unlock callback function. And then pool operator knows what to do, right? So that's why it's needed. Because you can do any operations in the unlock callback. You cannot do any of them before you reach unlock callback function. So what happens if I try to call this unlock callback function directly by some kind of malicious contract or by my EOA directly? If the pool operator doesn't protect unlock callback function, I can make it any operation. For example, in this example, I can make it withdraw the liquidity on behalf of some victim and transfer the tokens to my address, right? So the protection here is very similar. You also make sure, not only in the hooks contract, but also in the pool operator contract, that the unlock callback function is called only by the pool manager. Only pool manager can call your unlock callback function. And like, there's no case where somebody else might need to call that. The third case is a bit more complex, and it's about reinitialization of the hook. So here is an example of a different hook. This is a hook that calculates some dynamic fees, right? So dynamic fees is one of the features of V4, so they want to achieve that. And here you can see that the before initialize function is protected. There is that modifier called the pool manager only, right? So nobody else can call it. We are safe. But, well, what it does, it simply takes some pool key from the pool that is being initialized, their current price, and the block number when it started, when it was initialized, right? And also, the hook itself is a kind of pool operator because you can add and remove liquidity through this contract. So you as user can add liquidity calling the hook, and it does it on the pool, and then you can withdraw liquidity. And when you withdraw liquidity, you actually are making the pool operator calling the pool manager with this specific pool key that he saved during initialization, right? So you initialize the hook with the pool, and then on this pool, this hook will operate, right? So what happens if you try to initialize another pool with the same hook, right? So it's completely different pool because you cannot reinitialize the same pool. The only thing that you do is that you use the same hook address as the hook contract for the other pool. If you call it again, like if you initialize another pool with the same contract, the pool manager will call before initialize again, right? So it will again override the pool key. So when somebody wants to withdraw their liquidity, the pool operator will not try to make a call on the correct pool, the initial one. It will do it on a new one, which is probably a fake one because you just want to log their tokens, because that's what happens, right? Their tokens are locked. So to protect from that, you must use mapping. Well, you can either make sure that only one pool can be initialized using your hook, or if you want to support multiple pools, you can use mapping to store specific data related to the pool in this mapping with the key of pool key, right? Like on this example with pool data. Oh, there's a typo here. It should be pool data, not the poll data. Okay, number 4, impersonation of the sender. Here is an example of an interesting case, a hook that wanted to make sure that nobody can get more tokens than some threshold. So you have a token, and you just want to make sure that it's not collected in one address. Not too many tokens are collected in one address. So there is this after swap hook function that gets sender parameter. And what they do here, they check whether the balance, after the swap, whether the balance of this sender is over the threshold. If it is, they revert, because they don't want that, right? But if you look at the calls flow, you will see that the user, which they think is the sender, actually calls the pool operator calls the pool manager, and then pool manager calls the hook. So when the pool manager sends the sender to the hook, they send the address of pool operator, not the user, right? Okay, so the hook, the creators of the hook think that the sender is the user while it's pool operator. So that's how you can bypass their check very easily. But there is no impersonation yet, right? So stay with me. How can you fix it? Well, your pool operator can actually get the message sender of the user and send it in the hook data. So it reaches pool manager and is sent back to the hook. So that's how the hook can know what's the real address of the user. And what if I used a malicious pool operator and told the malicious pool operator that they should send not my address, but the address of some victim? This will be sent to the pool manager, and pool manager will send it to the legitimate hook. And if the legitimate hook doesn't check that, they will think that the victim just wanted to do some operation. And a great example of such exploits is abusing approvals. If there is an unlimited approval, then you can easily exploit it this way. And last two things. The first one is theft via dynamic fee. So basically, the fee can be up to 100%. If you think that the hook can be malicious, it can set the fee to 100%. If you try to swap without simulating the swap, you will lose everything, right? And then another thing is that if the hook is not malicious, you can actually end up with the fee being more than 100%. They tried here to calculate the fee. If you reach any situation that makes your fee over 100%, you have a denial of service, because pool manager will not allow to do that. They will revert any further swap. And last thing, quite easy, but I have to mention that, the upgradable hook. So the hooks can be upgradable. There is no protection from that. There are those permissions, so still there is some layer of security, but still the logic can be changed, for example, to 100% fee. So you still have to remember that the upgradable hooks is a real security threat. So I'm not going to go through that because I'm running out of time. So if you want to have some great takeaways, take picture of this slide. And you can also find me on Twitter or X, however you call it. Simply scan this QR code and you'll find me there, and you can ask me any questions. So if you're building or want to build a hook, that's a good thing to connect and ask some security-related questions. And last thing, we did a security research for Uniswap Foundation on Uniswap before. So we've got a series of blog posts on our blog, so you can check it out. It's on our composable security blog. And that's it from me. Thank you.
Thank you. We have time for one question, if someone wants to ask. Use this opportunity. Yes, please go ahead, David.
Just about what is your gut feeling that the evolution from version 3 to version 4 is increasing the, let's say, complexity and the surface of attack, and if this is well balanced with the new opportunities that probably the protocol, the foundation, they foresee?
Yeah, so actually this question is asked multiple times, almost every time I give this talk. Yeah, so it's about the modularity, right? All projects are now being modular and give a lot of power to the components, to the Legos that want to integrate with them, right? And also they delegate the risk to those, like to hooks. Hooks can simply steal your money if they are malicious. So there is a bigger opportunity to build on top of them and bigger risk. But what we proposed in the research is to build some kind of framework for users and builders to rate the hooks. Because, yeah, of course, simulation, like anyone who wants to build a front-end application that uses Uniswap v4 will have to do simulation before to show you what's the outcome, right? Because the logic in hook can completely change the logic of Uniswap, right? You may not expect what's going to happen. So that's why we need simulation. And then some kind of dashboard that shows you that these pools are, let's say, blessed because they used very well-known implementation or there are no hooks. So these pools are like V3, basically. These hooks are very common and were audited and are safe. There are no risks, like with because they are, for example, fixed fee. And here are hooks that bring some risk and like simply be aware of the threats that come from that.
Thank you so much.
Thank you.